Alright guys, so we're going to look at multiplying and dividing some indices. Now, when we multiply and divide indices, pretty simple rules, okay? And I'm going to show you exactly why this works. So let's say, for example, we had, say, 3 to the power of 4, and we wanted to multiply that by 3 to the power of 3, okay? Well, from previous lesson, we know that if we wrote this in expanded form, okay, if we wrote 3 to the power of 4, that'd be 3 times 3 times 3 times 3. Okay, so this guy here, 3 to the power of 4 because it's 3 written 4 times, okay? And then 3 to the power of 3 is 3 times 3 times 3, which is 3 to the power of 3, okay? And that makes sense if you think about it because, we've got 3 to the power of 4 and 3 to the power of 3. Now, in between them, there's a multiplication symbol. So we're going to do the same thing as well. Now, what you should notice is that, well, we've got 1, 2, 3, 4 threes on this side here, okay? And we've got a times in the middle, so this times pattern keeps going. We actually got 3 times 3 times 3 times 3 times 3 times 3 times 3. So how many 3s do we have all together? Well, we've got 3 to the power of 7, and it's that simple, okay? So what's the shortcut you guys can see from here down to here? Well, shortcut, it's pretty straightforward, I think. If you have 3 to the power of 4 times 3 to the power of 3, that's like doing 3 to the power of 4 plus 3, which is 3 to the power of 7. Because technically speaking, we're writing out 7 threes, okay? So it's going to be 3 to the power of 7 like that. So it's really important that you get into the habit of when you're timesing two things like this, you add them up. Now, this only works if you have the bases the same. So in this particular case, I had a 3 to the power of 4 and a 3 to the power of 3. So they were both 3s. Okay, if I had 3 to the power of 4 times 2 to the power of 3, then you cannot do this. It has to be the same base. Okay? So let's have a quick look at another one. So we'll call this one example number 1. Example number 2. Let's say we had, I don't know, let's use a letter this time. X to the power of 5, and then we just wanted to times it by an x. Okay, like this. Well, x to the power of 5, that's pretty straightforward. There's 5 x's there. How many x's does this one here represent? Well, hopefully you picked up on it and that there's only one. So technically speaking, we could write a 1 up there just so that we know that there's one x. And so we get x to the power of 5 plus 1, like this. Which means that our answer is going to be x to the power of 6. Because we have 5 x's here, so 5 x's. And we have 1 x here. So in total, when we're multiplying all these together, we should have 6 in total. So that's how we go about multiplying these indices. Now we're going to look at dividing. So this is for multiplying. So multiplying this was, so multiplying. Now dividing is pretty similar. Okay, dividing is pretty similar in the sense that we're going to essentially do the same thing, but with a minor little twist, okay? So let's start off with a problem, and we'll start off with this one. Okay, so 7 to the power of 9 divided by 7 to the power of 5, okay? Well, how can we write this another way so it's a bit easier to solve, okay? Well, I don't particularly like the division symbol. Another way we can write division is by writing as a fraction. So we're going to do that. We're going to write it as 7 over 9, 7 to the power of 9 over 7 to the power of 5, okay? And this one step just makes it a little bit easier to work out. Now, if you want, you can skip straight to this step if you prefer, if you don't need to do the first step of writing the fraction like it is. But I just wanted to show you that we can do it like this, okay? We're going to write as a fraction because what we're going to do now is we're going to write out our 7, how many times? 3, 4, 5, 6, 7, 8, 9 times. Okay? And we're going to divide it. How many times are we going to put it on the bottom? Well, 1, 2, 3, 4, 5. Okay. Now, whenever I see a 7 on the top, I can cancel it out with the 7 on the bottom. Excuse me. So whenever I see a 7 on the top, I can cancel it out with a 7 on the bottom. So I've got 1, 2, 3, 4, 5 on the top, bottom. So I can cancel it out with 1, 2, 3, 4, and 5 on the top. So my answer is 7 to the power of 4, because there's 4 7s left over on the top. Now, I wonder if you guys can see the shortcut for this one. Okay. So the shortcut for this one, pretty straightforward, is if you do 7 to, so if we rewrite this again, 7 to the power of 9, divided by 7 to the power of 5. Well, if you do 9 minus 5, okay, you're going to get your answer of 7 to the power of 4. Very, very straightforward in that case, I personally think. Okay. So essentially the rules are, if you're multiplying, you add the little powers together. If you're dividing, you subtract the little powers together. Okay. And that's pretty much it. We'll do one more. So if that was number 3, number 4, let's say we have x to the power of, we'll use a different letter. Let's say we've got m to the power of 10, and we want to divide it by m to the power of 8. Okay. Well, what's this equal to? Well, that's the same as m to the power of 10 minus 8. So it's equal to m to the power of 2. And that's pretty much it. Okay. So let me just write them down here. Rules. Okay, if you have m times a to the n, then you just add the little numbers. And then if you've got division, then you subtract the little powers like that. And those are the rules. So basically, they have to be the same bases. If you're timesing, you add the powers. If you're dividing, you subtract the powers. Pretty straightforward. I think you guys will be all over this. If you have any questions, though, feel free to ask. I'm more than happy to help.